I love the clean, modern look of LED strip lighting, but I absolutely hate it when they flicker and band on camera when the controllers use low PWM frequencies. So I said never again, and I bought basically every analog LED controller currently on the market. And today we're gonna figure out which one is actually the best. First, I'm gonna test their PWM frequencies both on camera and with a purpose-built flicker meter. Then I'm gonna explore all their LED behavior customization options. And last, I'm going to test how each controller integrates with voice control and Home Assistant and see which ones will work completely locally without the internet. For $15.99, the least expensive controller we'll be testing is the GLEDOPTO 301W, which uses Wi-Fi and the Tuya app for control. The 301W can handle 12 or 24 volts with a max of 6 amps on a single channel or 10 amps total. The 301W has 5 LED output channels with convenient lever lock style terminals that can fit up to 20 gauge ferrules or 18 gauge stranded wire. It's also got a small onboard button that can toggle the light and control dimming, and it's got an extra set of terminals to set up an external push button with the same functionality. In my testing, the GLEDOPTO 301W had an idle power of 0.408 watts with no LEDs lit, and when it was lighting up a 12 volt RGBW LED strip, the 301W had visible banding on camera at all dimming levels other than 100%, and my flicker meter measured a PWM frequency of 1000 Hz. Next, for $17.99 is the GLEDOPTO 201W, which also uses Wi-Fi and the Tuya app for control. The 201W can handle 15 amps of current on a single channel or 20 amps max thanks to its larger terminals. The 201W has the option of using a barrel style connector for its power supply or a lever style like the rest of its terminals, which can fit 18 gauge ferrules or up to 14 gauge stranded wire. Also, like the previous GLEDOPTO, the 201W has an onboard button that can both toggle and dim, and it has terminals to add an external push button. In my testing, the GLEDOPTO 201W had a much higher idle power consumption at 1.89 watts with the LEDs completely off. And it also had very visible banding at all dimming levels and the same 1000 Hz PWM frequency. After that, for $17.99 is the GLEDOPTO 201P, which looks basically identical to the 201W, but it uses Zigbee instead of Wi-Fi for control. The 201P has the same current limits at 15 amps on a single channel and 20 amps total, and it's got the same barrel jack connection and lever lock style connectors. But the on-off dimming button on the 201W has been replaced by the reset button on the 201P that's used to pair it with your Zigbee hub. However, the 201P does still have those terminals for a push button, which supports push to toggle and hold to dim functions. The 201P had an idle power consumption of 0.744 watts, which is half as much as the 201W, but it showed banding at all dimming levels, and it had the same 1000 Hz PWM frequency. Next, for $19.88 is the ATHOM WLED analog strip controller, which, as the name suggests, is a Wi-Fi controller that uses WLED firmware. The ATHOM controller accepts voltages from 5 to 24 volts, and it can support up to 16 amps total output, and it's got both barrel and screw terminal power connectors. The ATHOM also has more standard style screw terminals for its outputs, and it can fit up to 14 gauge ferrules or 12 gauge stranded wire. The ATHOM controller has an onboard button that can be configured in WLED, but it doesn't have any terminals to wire an external button. However, the ATHOM controller does have 2 additional connections, a JST connector for an optional IR remote, and an extra data and ground port to connect an addressable LED strip. In my testing, the ATHOM controller had a low idle power consumption of 0.444 watts when it had no LEDs lit, but it did show banding on video with a PWM frequency around 900 Hz when it was set to its normal clock in WLED, and unfortunately it still showed some banding even when it was set to the faster clock speed, despite being at the upper limit of what my PWM flicker meter could register. After that, for $19.90 is the LED controller that I've been using for the last 4 years in almost all of my projects, the Shelly RGBW2, which is mostly discontinued at this point. The RGBW2 uses Wi-Fi and is controlled with the Shelly app or the web interface, and unlike the rest of the controllers in this video, the RGBW2 is only a 4-channel controller instead of 5 channels. So it only officially supports RGBW strips and not RGB CCT strips. The RGBW2 supports 12 or 24 volts, but it does have the lowest single channel current limit of any of the controllers in this video at 3.75 amps, but it does support up to 12 amps total. The RGBW2 has slightly smaller screw terminals than the ATHOM controller and can only accommodate 18 gauge ferrules or 16 gauge stranded wire. And it also has an input terminal that supports programmable push button functionality. The RGBW2 had the lowest idle power consumption yet at 0.336 watts, but it showed banding on camera, which is definitely extremely consistent with my previous experience, and it's the ultimate reason that I'm making this video in the first place. And like the Wi-Fi controllers from GLEDOPTO, my flicker meter showed a PWM frequency of 1000 Hz. Next for $19.99 is the Pautix WL5, which uses Wi-Fi and is controlled with the Tuya app. And despite being called the Pautix WL5, it's actually labeled Mi Boxer on the unit itself and in the Tuya app. The WL5 has a barrel connector and traditional screw terminals, and like the ATHOM, it can accommodate 14 gauge ferrules or 12 gauge stranded wire. The WL5 supports 12 or 24 volt strips, and it has a current limit of 6 amps per channel or 15 amps total. And the WL5 doesn't have any buttons to control the LED strip or terminals to connect the button. In my testing, the WL5 had a slightly above average idle power consumption of 0.78 watts, but it is the first controller so far to not show banding or flickering on camera throughout its entire dimming range, and it has a PWM frequency far exceeding what my meter could accurately measure. Following that up for $20.99 is the BTF-Lighting C05Z, which uses Zigbee for control, and the C05Z is a little bit smaller than most of the controllers so far, and it says that it accepts 5 to 24 volts via its barrel jack or screw terminals, and it supports a max current of 6 amps per channel or 15 amps total. But there is no chance that you could get close to those numbers since it's got little tiny screw terminals that only accept 22 gauge ferrules or 20 gauge stranded wire, and pushing it to 15 amps would easily melt 22 gauge wire. The C05Z also doesn't have any buttons for LED strip control, and it also doesn't have any terminals to connect an external button. In my testing, the C05Z had an unbelievably low idle power consumption at just 0.156 watts, which is great, but it did have significant banding on camera at all of its dimming levels with a measured PWM frequency of 1000 Hz. Moving on to the GIDEALED Z C05M-20 for $21.99, which is a Zigbee controller that's almost completely identical to the GLEDOPTO 201P. And it's got the same terminals, voltage compatibility, and current limits with both barrel and lever lock style terminals, and it accepts 18 gauge ferrules or up to 14 gauge stranded wire. And it's got a screw terminal for an external button. Also, like the GLEDOPTO, the GIDEALED had an idle power consumption of 0.744 watts, and it had significant banding at all dimming levels, and I measured a PWM frequency of 1000 Hz. In other words, this controller is exactly the same as the GLEDOPTO 201P, other than a $4 increase in price. Next for $23.99 is the BTF-Lighting C05W, which uses Wi-Fi and it's controlled by the Tuya app. And this one is basically identical to the C05P, and it's got that same form factor with the barrel jack and tiny screw terminals that only accept 22 gauge ferrules, and the C05W also doesn't have any button terminals. The C05W had an idle power consumption of 0.576 watts, which is over 3 times higher than the Zigbee version, and it still had significant banding on camera at all dimming levels with a measured PWM frequency of just 510 Hz, which is the worst yet. After that, for $24.99 is the replacement for the Shelly RGBW2, which is called the Shelly Plus RGBW PM, which really just rolls off the tongue. Like the RGBW2, the RGBW PM is Wi-Fi, and it uses the Shelly app or web interface for control. And this new Shelly RGBW PM is easily the smallest controller in the video, but it does have some major downfalls as a result. First, like the RGBW2, the RGBW PM is only a 4-channel controller, so it doesn't support RGB CCT LED strips. Second, because they chose to include 4 different button inputs, each of the screw terminals is extremely small and just barely fits a 22 gauge ferrule or 20 gauge stranded wire. And last, the RGBW PM doesn't have any pass-through terminals to power your LED strip, so you'll need to use some other lever lock or wire nut to split the power supply cable between the strip and the controller. Though this may have been a purposeful design by Shelly to help them increase the maximum supported current, and the RGBW PM accepts 12 and 24 volts and has a current limit of 4 amps per channel and 10 amps total. In my testing, the Shelly RGBW PM had an idle current of 0.6 watts, which is about average, but I am happy to report that it's now the second controller to have 0 banding throughout its entire dimming range, which is pretty odd since my flicker meter measured a PWM frequency of just 849 Hz, but that actually indicates to me that the frequency is well above what I can reliably measure, and the Shelly Plus RGBW PM even has a high frequency mode, which it says can help eliminate power supply whine, and that I measured at 2.2 kHz, And it also had zero banding on camera, but again, I'm guessing the actual frequency was much higher. Next, for $26.99 is the EMITEVER 1501, which is another Wi-Fi controller that uses the Tuya app, but it appears to be a unique design from all the other controllers in the video. The 1501 supports 12 or 24 volts, and it's got a max of 3 amps per channel or 15 amps total. The 1501 has both barrel and screw terminal power connectors and fairly large screw terminal outputs that just barely fit a 14 gauge ferrule or 14 gauge stranded wire, and the 1501 has no onboard buttons to control the strip, nor terminals to add them. In my testing, the EMITEVER 1501 had an idle power draw of 0.744 watts, and it showed noticeable banding at all brightness levels with a PWM frequency of just under 1000 Hz. After that, also for a price of $26.99 is the BTF-Lighting WB5, which is a Wi-Fi controller that again uses the Tuya app. The WB5 supports 12 and 24 volts and has a maximum output of 6 amps per channel or 15 amps total, and uses press to connect terminals that just barely fit a 16 gauge ferrule or 16 gauge stranded wire. And like the last few controllers we've seen, the WB5 also lacks any buttons for controlling the strip or terminals to add them. In my testing, the WB5 had an idle power draw of 0.29 watts, which is excellent for a Wi-Fi controller, and it is now the third controller to not show any signs of flickering or banding on camera throughout the entire dimming range. And again, the PWM frequency on this one was definitely too high for my flicker meter to make sense of it. Following up on that, also for $26.99 is the Zigbee version of that same controller, which is called the BTF-Lighting LM052, with all the same stats and connections. 12 to 24 volts, 6 amps single channel, 15 amps total, and press to connect terminals for 16 gauge ferrules and stranded wire. In my testing, the LM052 had an even lower idle power draw than the WB5 at just 0.18 watts, and like the WB5, the LM052 showed zero banding throughout the entire dimming range with PWM frequencies that were too high for my flicker meter to measure correctly. Jumping up quite a bit in price, we've got the QuinLED An-Penta-Mini, which is a Wi-Fi controller that runs either WLED or ESP-Home and supports 12 to 48 volt inputs, with a maximum output of 5 amps per channel or 10 amps total. The An-Penta-Mini has big screw terminals that fairly easily fit 14 gauge ferrules or 12 gauge stranded wire on the input side, and it's got 2 outputs with the same wire capacity that are intended for the warm and cool white channels, and then there are 3 smaller outputs for the RG and B channels. And the An-Penta-Mini also has 3 button inputs on the opposite side, which are configurable via WLED or ESP-Home. In my testing, the An-Penta-Mini had an idle power consumption of 0.672 watts, which is slightly above average, but it had absolutely zero flickering or banding throughout the entire dimming range, and even on normal clock mode, my flicker meter was nowhere close to being able to measure the PWM frequency of the An-Penta-Mini, which I heard from QuinDor is somewhere around 19,000 Hz. And in WLED, if you select the fastest clock rate, that frequency goes up to around 80,000 Hz. And last, if an An-Penta-Mini didn't quite fit your needs, there's also the $44 An-Penta-Plus that triples in size, adds Ethernet, and increases the maximum current per channel to 10 amps or 30 amps total. The An-Penta-Plus also increases the size of its power input terminals to accommodate massive 12 gauge ferrules or 10 gauge stranded wire, and you can double that up to safely feed the board 30 amps of current. And speaking of safety, in true QuinDor fashion, the An-Penta-Mini and An-Penta-Plus both have internal fusing on each of the positive outputs. In addition to the larger power inputs, each of the power outputs is also larger and can fit 14 gauge ferrules or 12 gauge wire, and there are power injection outputs for both of the white channels. And on the power output side, there are a total of 4 positive voltage outputs. And on the far side of the board, the An-Penta-Plus also has an output for an addressable LED strip. All this extra power and functionality does come at an extra cost, and I measured the idle power consumption of the An-Penta-Plus at 1.03 watts, but as you would expect from the care taken to design this board, there was absolutely zero flicker or banding on camera throughout the entire dimming range, and my flicker meter had absolutely no chance of measuring the ridiculous high PWM frequencies on the An-Penta-Plus. So that means out of the 15 LED controllers, only 6 of them had a high enough PWM frequency to avoid flickering when dimmed, which was my main selection criteria. But I also tested their thermal performance by running 2 5-meter 24-volt RGB CCT cob LED strips at full brightness for 30 minutes and then recording their maximum temperature with a thermal camera. And almost all the results here were completely uninteresting. And with these two strips only being able to pull around 5 amps total, none of the controllers had any issues dissipating the heat, and the only even mildly concerning results were from the GLEDOPTO 201W, which had a single component that was significantly hotter than the rest, and the Shelly RGBW PM, which showed the downfall of using small terminals and thin wires, and the tiny 22 gauge wire that I was using with it heated up to over 50 degrees Celsius. The next most important thing to me was being able to control the LED strips exactly how I want to. I tested each controller and I scoured their respective apps for power on options, and I found that these 11 controllers were able to start up instantly when powered on, while the BTF-Lighting C05W and WB5 power on directly to a dim light source for a second before returning to their previous state, and the Shelly RGBW has a brief flash and then a 1-second delay before returning to its configured state. And the new Shelly RGBW PM has that same 1-second delay, but it doesn't have the initial flash when it first receives power. For their programmed power on behaviors, these 4 controllers will always turn the LED strip on to its last brightness and color state whenever it gets powered up. The Ideal LED and GLEDOPTO 201P can configure their power on state via Zigbee in Home Assistant. The Pautix WL5, BTF C05W, and BTF WB5 are configurable in the Tuya app. The Shelly controllers have their power on state configured in the web interface, and the WLED controllers are configurable to a certain extent, but in order to have them remember the last state that they were in, you need to install a special user mod that's called autosave, which is not included by default. The next important aspect for me was being able to change the options on the controller to accommodate different LED strip types. So starting with the Shelly controllers, as I mentioned earlier, they only have 4 outputs, so they don't support RGB CCT LED strips that have both cool and warm white and need 5 outputs. But you can set up the Shelly controller as an RGBW controller or as 4 separate white channels. And the major benefit of the Shelly RGBW control is that you get a separate slider for the white channel, so you can mix colors with the white channel as much or as little as you want. And on the 4-channel white mode, you get a separate brightness slider for each of the channels. WLED definitely has the most granular control, where you can set up basically any strip type, multiple strips, multiple outputs, you name it. And you can also control how it handles the combination of white and color channels, and you can optimize it for things like maximum brightness or maximum color accuracy. 8 of the 15 controllers have a push button that toggles between different modes, and the documentation for those modes is terrible. The first one is RGB CCT mode that does pretty much exactly what you would expect and gives you a separate control for color and then one for white that has a color temperature and brightness slider. RGBW mode is similar, but it combines the 2 white outputs, which allows you to get more brightness overall at the cost of controllable color temperature. RGB mode just removes the white controls from the Tuya app and the Zigbee control, and it only uses the 3 channels. CCT mode gives you 2 separate outputs of controllable white, where the cool white and blue outputs are then used for the warm white channels, and the green and the red outputs are used for the cool white channels. And the 5th mode is just called dimmer mode, and it outputs the same signal to all 5 channels and gets you a single brightness slider for control. And last, we need to test how each of these controllers works with different smart home platforms, and by far the most common platform used by these controllers is the Tuya app. And the good news about Tuya is that it is relatively easy to use and seamlessly integrates into Amazon Echo, Google Home, SmartThings, and Home Assistant. But the bad news is that it is a cloud-based dependency, so if your internet goes down, you will lose control of your LED strips, and if you're someone who wants to block your IoT devices from the internet, you cannot easily do that with Tuya. On the opposite end of the spectrum is WLED, which is an open source, local-only firmware that integrates easily with Home Assistant via built-in API, and it's got MQTT support and support for Amazon Echo. But all that does require a little bit more setup and know-how than Tuya does. Shelly falls somewhere in the middle of those two, with cloud and local options and simple integration into Amazon Echo, Google Home, and Home Assistant, but the Amazon Echo and Google Home solutions only offer brightness control and not color. And the ultimate local-only solution is Zigbee, which requires a Zigbee hub or a Zigbee dongle, and any other integrations into things like Amazon Echo and Google Home are going to be handled through that specific hub. And for this video, I used Home Assistant with ZHA and a Texas Instruments CC2531 Zigbee receiver. So after all that testing, which LED controller am I going to choose? Personally, flickering and banding for me is an absolute deal breaker. So that narrows it down to just these 6 options. And if you're looking for something that's just plug and play with Amazon Echo and Google Home Control, I think that the $19.99 Pautix WL5 is the best option due to its configurable power on behavior, configurable LED strip type, no banding or flickering, and nicely sized screw terminals that can accommodate 14 gauge ferrules, with the only downsides being it not having any connections for an external button and the fact that it runs on Tuya, which is a cloud-based service. If you're looking for a Zigbee option, the only controller that didn't have flickering was the BTF-Lighting LM052, which also had very low idle power consumption and decent sized, easy to use press fit terminals. But the downsides of the LM052 are that it doesn't have any external button connections, its power on state defaults to on and isn't configurable, and in Home Assistant you can't have the white channels on at the same time as the RGB channels when it's set up as an RGB CCT controller. For a local control Wi-Fi solution, I think that the Shelly RGBW PM, QuinLED An-Penta-Mini, and An-Penta-Plus are the clear choices. The downsides of the Shelly RGBW PM are its extremely small terminals, lack of a 5th channel for RGB CCT strips, and the small delay on power on. But its small size, 4-button input terminals, and local interface are extremely convenient, especially if you're going to be setting up 4 different white LED strips instead of an RGBW strip. The An-Penta-Mini is extremely thoughtfully built and be configured basically any way you want inside of WLED. But with all those customization options, changing settings isn't as simple and foolproof as it is with other controllers, and by default there is no option to remember the last state on power on. The increased build quality also comes at a cost, and it's over $10 more than the Shelly, and it's over 3 times larger. And last, the An-Penta-Plus is basically an industrial design with significantly more power handling than most people are ever going to need. It's also got Ethernet connectivity and tons of customizability, but it is massive even compared to the An-Penta-Mini, and by far it is the most expensive controller in this video, which based on its build quality is totally justified, but for most people the design and specs are definitely overkill. However, if you just want the absolute best, no matter the cost or size, this is definitely it. As a reminder, there are no sponsored reviews on this channel, but I do have links to all the controllers down in the description, and as always, I appreciate when you use those links since as an Amazon affiliate, I do earn a small commission on the sale at no cost to you. I'd also like to thank all of my awesome patrons over at Patreon for their continued support of my channel, and if you're interested in supporting my channel, please check out the links down in the description. If you enjoyed this video, please consider subscribing, and as always, thanks for watching The Hookup.